So today we're going to learn about the Pythagorean theorem. Pythagoras was an ancient Greece mathematician who discovered things such as the golden ratio, which is involved in music, but also discovered a formula, a squared plus b squared equals c squared, to help us find the different sides of right triangles. So let's draw us a little right triangle, and we know that a right triangle has a 90-degree angle and two other acute angles. So we're going to, in this example, use 45 and I do believe 60. But we need, hold on, not 45 and 60. You need to make sure your angle degrees add up to 180, and if you add those together, you don't get 180. So let's change that 45 to, I do believe, 30, yes. And so now that we have our angles, we know that in order for it to be a right triangle, all angles have to be acute, and the acute angles also have to add up to 180 degrees. So let's just prove that real quick. And so using this formula to solve the different sides of the triangle can be really helpful. So let's also label our sides so this way we know which sides we're going with. In the right triangle, the hypotenuse, which is C, is always going to be C. And your following corresponding sides can be either A and B. It's not really any difference between the two. So let's make up an example where we have A equals 3, side length of B equals 4, and we're not too sure what C is. So let's fill in the different sides of the triangle so we can better see our example here. So I have the 3 and the 4. We're going to use a pretty color blue to differentiate that those are the sides we know. So using the formula, a squared plus b squared equals c squares. We can fill in what we know, a and b, and then just simplify to see what we can get for side c. So we have 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. And then if we add those together, we get c squared equals 25. And following that, we get c equals the square root of 25 because we have to simplify just for c. And we get c equals side length of 5, which is correct.